Hello guys, welcome to my YouTube channel, and in this video we are going to solve one mini project on bank term deposit predictions. So basically in this project we are going to do the classification task, whether the person is likely to do the term deposit, yes or no. So for that, first of all we will import the libraries and will start our operation. And in this particular problem, why I have selected is because I want to apply principal component analysis. As you can see, there are many columns in this data sets, and we want to do the dimensionality reduction. So that's why we will use principal component analysis. In this video we will learn basically about how to apply principal component analysis and do the classification task. So let's just import the libraries and start our task. Import numpy as np, import pandas as pd, import matplotlib pyplot as plt, and import seaborn as sns. So first we will import all the necessary libraries. Now we will import our data set. So for that I will write df equal to pd dot read csv, and in this first of all I will and after this I will see the first 5 rows, importing the data set, and we have seen the first 5 rows. So basically over here age column is there, which mention the age of the customer. Then there is a job column over here where what kind of job profile he is doing, the occupation and employment status of the customer. Marital is whether he is single or married or divorcee. So education, the education level attained by a customer, that is whether he is primarily educated, secondary or tertiary. And default is whether the customer has credit default or not. So default column tells us like that. So first of all we will perform some basic pandas function like dfinfo to get the idea about our columns. So there are total 45,211 rows in this training data set, and some are categorical variables and some are numerical variables in this data set. So for first of all what we will do, we'll check for the null values. Is null dot sum, whether our data is having null values or not. So it clearly shows that there is no null values in our data set. Now we'll perform describe function over the numerical columns of the data set. So age, balance, day, duration, campaign, p days and previous are the numerical columns over here. Now first of all we'll do the data visualization. To understand bit about our data. So data visualization. So first of all what I will do, I will start with the age column over here and try to plot a histogram to understand how the distribution of our customer ages are there. So for this, what I will do is write plt dot hist, and in bracket I will provide df, and what's the column, that is age. How many bins I will provide is another. So for bins I will say 20 bins, and edge color equal to black, and I will write plt dot title, and in title I will mention distribution of the customer age, and I will write plt dot x label, and I will mention x label as age, and plt dot y label I will mention as the frequency of this age, frequency, and I will write plt dot show. So this will plot our first data, age over the age column, the distribution of customer age. So basically the distribution of customer age is little bit normally distributed. It starts with age of 20 and expand up to age of 70. Mostly entire data is between 20 to 70 years of age. So now what I will do, I will go through job column and I will try to count plot it. So for this, what I will do, plt dot figure, and in figure I will mention fig size and pass the tuple over here, that is 12,6, and what I will do, sns dot count plot, and in count plot I will mention x equal to the column, that is job column, and I will pass data equal to df. Now what I will provide is title, and title will be count of customer by job, and I will mention plt dot x label is equal to job, plt dot y label is equal to count, and plt dot x ticks, so we will mention the rotation equal to 45, and plt dot show. So this gives us the clear idea about our data, that blue collar management and technicians have the large numbers of count in this job data. Now what I will do, I will check the balance and I will try to find out the outliers in it, because this column is also important. So what I will do over here is I will write plt dot figure, and and in figure I will mention fixed size, and in this fixed size I will tell 10,6 and plt not plt sns dot box plot, and in box plot I will mention x equal to y and y equal to balance, y equal to balance and data equal to df. So this will prepare a plot. Title and title will be box plot of balance by deposit outcome and I will write plt dot x label. And what should be the x label? X label should be deposit outcome, and plt dot y label. In this I will mention balance, and lastly I will try plt dot show. So we can clearly see that according to the term deposit, whether the person is making term deposit or not, there are some outliers in this values of deposit outcome and balance. Yet now we will try to detect the correlation between various columns of our data set. In this all 17 columns, we'll try to see whether there are some correlation between them or not. If there is highly correlated values, then we will try to remove those, and if there is no correlation, then our data is ready to go. So numeric underscore columns is equal to df dot select d types, and in d types I will write include equal to float 64 comma int 64 dot columns, and numeric underscore data is equal to df, and in df I will mention this numeric columns. Now I will prepare one correlation matrix, and that will be numeric data dot cor that will calculate the correlation. Now I will try to plot it in the heat map, this correlation. So fixed size, it will be fixed size of 12.8, and I will mention plt sns dot heat map, and in this I will mention value as correlation matrix anode equal to true, cmap is equal to cool warm, and FMT is equal to 0.2F and line widths equal to 0.5. So what I will do, plt dot title, in title I will mention correlation heat map, and I will mention plt dot show. Okay, there is some error, float 64 not understood. Okay, so we have given space, that's why it is not understood. So now what I will do, so we can clearly see this heat map, and according to heat map there are no values which is highly correlated, or in positive terms or in negative terms. In both terms there are no values that are highly correlated. So what we will do, we will not remove any of the columns from this correlation heat map. Now what I will do, we'll check for the marital status and we will try to count it. So for this what I will do, marital status counts equal to df marital dot value counts and I will try to draw a pie plot. Plot.py, I will mention marital status counts, what will be the labels, is equal to marital dot index and auto PCT equal to percent 1.1 F percent and will mention start angle equal to 90. plt dot title is equal to marital status distribution and plt dot show. So this pie chart shows that 60% people are married and 28% people are single and 11% are divorced. So what I will do for the rest of the columns, for visualization I will use pair plot and I will write the code data equal to df diag equal to KDE and markers equal to asterisk and hue equal to y, what I will do, plt dot title, and I will mention distribution no, for this I will directly, because distribution it will show entire data, so plt dot show. And finally we'll try to correlate job and education and try to deduce the relationship between. As the pair plot is getting drawn, we can proceed further until it gets uploaded, and I will mention fixed size (20,6) and plt dot title distribution of job categories across education level. So plt dot xticks, and I will mention rotation equal to 45, ha equal to right, and plt dot show. So still our SNS plot is not prepared. It takes some time because data is huge. So our pair plot is ready, and data looks like, according to scatter plot, is neither positively correlated or negatively correlated, and I see the data is like uniform and have proper distribution as the pair plot shows. And I have not plotted distribution over here, so for that I will use SNS dot count plot distribution of job, and so data equal to df and x equal to education and y equals like hue is equal to job. So it shows the distribution of job categories according to all education levels. So there are 4 education levels. One is unknown, another is primary, secondary and tertiary. Now when we have visualized the data and found out that it's good to go for our model building. So what I will do over here is, because there are 17 columns including our target column, which tells whether the term deposit will be done or not, yes or no. So there are all in total 16 columns. So I will try to use principal component analysis and reduce these columns to 2 for our model building and do the classification. So for first of all, for applying principal component analysis, we have to standardize our data, and for that first we have to apply the encoders to convert all categorical values into what we say sklearn dot categorical values into numerical values, pre-processing, import label encoders, and from sklearn dot pre-processing import standard scalar. So first of all, we will convert our all categorical columns, which is job, marital status, education. So I will include one by one and do the label encoding with them. So for this, first of all, as our data is clean, I will directly call our test data test data and apply standard scalar over it. So this I welcomed it. Now label underscore encoder equal to label encoder. Now first I will describe all the categorical columns equal to, I will mention one by one all the categorical columns, that is job, marital status. First categorical column is job. Next is marital status. Third is education. Third is education. Fourth is default, is also whether they will default on loan or not, is also categorical. And now another is housing loan. Housing, loan, contact month and out. Contact month and Y. And Y. So these are our all categorical columns. For column in categorical columns, what I will do, df1 column is equal to df1. What I will do over here is label encoder dot fit transform, and here I will mention df1 column. So first of all it get transformed. Now what I will do over here is apply standard scalar, because whenever we want to apply a principal component analysis, that is dimensionality reduction, reducing all the columns from 16 to 2, or we will try to reduce it in 2, and demand from 16 dimension of our data we will reduce it to 2 dimension. So for that, what I will do, first of all I will apply standard scalar. Features is equal to df1 dot iloc. I will separate the x part first of all before applying -1. So we have segregated out, and I will check the features first. So all the columns is been selected out. Now what I will do, the data is proper, I will apply standard scalar. Standard scalar and feature scaled equal to scalar dot fit transform, and in this I will pass features, and we have applied the standardization. Now what I will do, I will apply principal component analysis. For that, what I have to do is first of all import the libraries from sklearn dot decomposition, import PCA from sklearn dot metrics, import accuracy score from sklearn. We will use dot model selection, import train test split from sklearn dot ensemble, import random forest classifier. After doing this, I will apply PCA on our X PCA, and in components I will define n components and principal components lengths equal to PCA dot fit transform, and I will mention over here feature scale. Once it is done, I will convert this into data frame so that we can visualize our data, how this principal component analysis have worked or not. So for that, PCA df equal to pd dot data frame, and in this I will apply data equal to principal components and columns equal to PCA1, PCA2, and this should be in the list form. Now what I will do is try to plot it. Figure, and I will pass fig size equal to 10.8. SNS dot scatter plot x equal to PCA1, y equal to PCA2, and u equal to df1 y, and data equal to PCA underscore df. So I will apply plt dot title and I will mention PCA principal component analysis, and I will mention plt dot show. So this is showing our how our dimensionality has been reduced, and still what is the ratio of the y in terms of scatter plot. So now we will try to build our model after making a split in our data set, that is x train comma x test comma y train comma y test equal to train test split, and data is equal to principal component data, that is principal component data, that will be our x, principal components, and y equal to dfy df1 df1 dot y, and test size 0.2, and random state equal to 30. Now once the division is done, we will try to build a model based on random forest, that is model RF equal to random forest classifier, and in this we will mention n estimators equal to 150. We are hypertuning our random forest. Max features equal to auto, and max depth equal to 4, and criterion is equal to entropy. And what we will do, model RF dot fit xtrain ytrain, and model underscore RF dot score is equal to xtest and ytest. Xtest and ytest. So xtest is not defined. अच्छा, xtext हो गया. So it is xtext. Our variable is xtext. So we got the accuracy of 87% in it, as the score is showing that, and we have correctly classified our data for Bantam deposit, whether they are going to make it or not, and its accuracy is 87%. Thank you guys. This much in this video, and in next video we will try to look at some other different projects and better than this project. Thank you guys.